In today's lesson, we will continue with operations with radicals. And we're going to start with multiplying two binomials together that have square roots in them. And you can choose whether or not you want to do the FOIL method or the box method. I will do one of each, and then you can try one on your own using whichever choice that you like. So first, let's do the box method. Okay, so we have the binomial square root of 5 minus 2 square root of 15 times the binomial square root of 5 plus the square root of 15. So for the box method, we of course first have to draw a box. Okay, so here's my box, and I have the two binomials on each side. And I'm just going to fill in my box. So first, the square root of 5 times the square root of 5 would be the square root of 25, which is just 5. And then the square root of 15 times the square root of 5. This time you can actually multiply 5 times 15 because they are both underneath square roots. So that's the square root of 75. And then here, let's see, negative 2 times, you could think of it as just 1, is negative 2. And then you can multiply your two square roots together, square root of 5 and square root of 15, which again is the square root of 75. And then the last one, I have negative 2 and then square root of 15 times the square root of 15. So that would be negative 2 and then times the square root of 15 times the square root of 15 cancels out the square root, and I'm left with 15. So that technically would equal negative 30. So now, let's look. I have like terms on this diagonal, but I also have like terms on my other diagonal. So, let's think about this. I have 5, and I have negative 30, and then I have the square root of 75 minus 2 square root of 75. So I can combine them together. 5 minus 30 is negative 25. And then I have 1 square root of 75, and I'm taking away 2 square roots of 75, so that's minus the square root of 75. However, we are not done because the square root of 75 is not simplified. Okay, so we have to simplify that square root of 75. So I still have negative 25 minus, let's break up 75 into 25 times 3, where 25 is a perfect square and the square root of it is 5. That comes out in front. So now I have negative 25 minus 5 square root 3. Now that right there is my final answer. Common mistake that some students do is they try to then combine the negative 25 minus 5, but those are not like terms because the 5 has the square root of 3 attached to it. So you cannot combine those two terms, and that actually right there is your final answer. For the next example, we're going to use the FOIL method. But if you prefer the box method, you can try using the box method and then just check your answer at the end. So for this example, we have 2 square root of 6 plus 3 square root of 3 times the square root of 6 minus the square root of 3. We're going to use the FOIL method, so remember that FOIL stands for first, outside, inside, last. But let's do one at a time. Let's start with the first. And each time that you multiply, you're going to multiply the coefficients together and then multiply the radicals together. So in this case, the coefficients are 2 times 1, so that's 2. And then our radicals, the square root of 6 times the square root of 6, cancels out the radicals and leaves you with just 6. And then 2 times 6 is 12. Okay, let's do the outside. Multiply the coefficients together. 2 times negative 5 is negative 10. And the square root of 6 times the square root of 3 is the square root of 18. Okay, inside, 3 times 1 is 3, and the square root of 3 times the square root of 6 is the square root of 18. So first outside, inside, and then last, multiply the coefficients. 3 times negative 5 is negative 15, and then the square root of 3 times the square root of 3 cancels out your square roots and leaves you with just 3, and negative 15 times 3 is negative 45. And now we have our middle terms that are alike, so we can combine them. Negative 10 plus 3 is negative 7 square root of 18. And we also have our first and our last terms that are alike that we can combine. So 12 minus 45 is negative 33, and then we have our minus 7 square root of 18. Now we're not quite done yet because the square root of 18 is not simplified all the way. So let's break it apart. Negative 33 minus 7 square root of, let's break apart 18 into 9 times 2, where 9 is the perfect square, and the square root of 9 is 3, so 3 will come out in front and be multiplied by that 7. So now we have negative 33 minus 7 times 3 is 21, and then square root of 2. And that is your final answer because the last two terms are not like terms, so you cannot combine them any further. Okay, here's our last example with FOIL, or the box method. The square root of 7 plus 4 squared. Now, biggest mistake you can do right here is to distribute that exponent, because when you have a binomial squared, it means that you have the square root of 7 plus 4 times itself. The square root of 7 plus 4 again, and then from there you can use the box method or FOIL. For right now, I'm going to use FOIL. So let's do first, the square root of 7 times the square root of 7 is 7. And then outside, 4 times the square root of 7 is 4 square roots of 7. And then inside, once again, we have 4 square roots of 7. And last, 4 times 4 is 16. And we can combine our middle terms while we also combine our first and last. So 16 plus 7 is 23, and then 4 square roots of 7 plus 4 more square roots of 7 is 8 square roots of 7. And everything is simplified. We cannot combine our last terms, so there we have our final answer. Okay, in the next part of our lesson, we're going to have examples where we have fractions in which the denominator is a binomial with radicals. And remember, your final answer cannot have a radical in the denominator, so we have to rationalize it. However, it's a little bit different when you have a binomial of radicals in the denominator in which we have to rationalize. So, to do it, we have to multiply by the binomial's conjugate. Conjugate means, basically it's like you take the binomial and then you multiply by its opposite. So let's say this is in the denominator, its conjugate, instead of addition, would be subtraction, and then vice versa. So let's, real quick, multiply these two binomials together and see what happens. We've got square root of a times the square root of a is just a. And then outside, this would be minus the square root of ab. And then inside, plus the square root of ab. And then last, the square root of b times negative the square root of b would be minus b. And then our middle terms cancel out, and we're left with a minus b. So whenever you multiply a binomial by its conjugate, it will always cancel out any square roots and leave you with an integer. So that's what we need to do in order to rationalize our denominator. Okay, so the first example is 6 divided by the binomial, the square root of 5 minus the square root of 2. So, no radicals in the denominator, so we have to rationalize it. So remember, you multiply by a fraction that is equal to 1. And this time, you multiply by the binomial's conjugate. So I'm going to multiply by the square root of 5 instead of minus. It's going to be plus the square root of 2. And that is on top and bottom. Square root of 5 plus the square root of 2. So now, when we multiply 6 times this binomial, normally you would think distribute, but I'm actually going to tell you to hold off on distributing, and you will see why. I'm just going to leave it as 6 times that binomial square root of 5 plus the square root of 2. We're going to distribute at the end. So now, look at my denominators. If you FOIL that, first, outside, inside, last, what just happened when we multiplied their conjugates? Those middle terms always cancel out, so the outside, inside terms. So all you really have to do are multiply your first and last terms together. So the square root of 5 times the square root of 5 is just 5. And then negative square root of 2 times the square root of 2 would just be minus 2. So now, 5 minus 2 is 3. So I am left with 6 times the square root of 5 plus the square root of 2, all divided by 3. And this is why I wait to distribute that 6, is because when you have a number out in front like this, you can simplify with whatever was left over in the denominator. 6 divided by 3 is 2. So now I have 2, the square root of 5 plus the square root of 2, and I will distribute at the end. So now you can multiply both of them by 2, which is simply 2 square root of 5 plus 2 square root of 2. So I took my original problem, got the radicals out of the denominator by rationalizing it, by multiplying by its conjugates, and I'm left with that. Alright, our next example, 4 divided by the binomial square root 7 plus square root 5. Let's rationalize this denominator by multiplying by that binomial's conjugate. So, multiply by a fraction that equals 1, and the conjugate of this binomial is square root of 7 and the square root of 5, but since we have addition, its conjugate will have subtraction. And then that also goes on the top. Okay, let's multiply these together. When you multiply 4 times that binomial, remember, hold off on distributing. So we just have 4 times square root 7 minus square root 5. And then when you multiply the two binomials, your outside and inside terms will cancel, so you only have to multiply first and last. Square root of 7 times the square root of 7 is 7. The square root of 5 times negative the square root of 5 is minus 5. So, I have 4 times the binomial square root 7 minus square root 5, all over 7 minus 5 is 2. And then look to see if you can simplify your coefficient with the denominator. 4 divided by 2 is 2. So I have 2 times the binomial square root 7 minus square root 5. And the last step, distribute the 2. So 2 square root of 7 minus 2 square root of 5. And there you go. Here's the last example of the lesson. Why don't you write it down and pause the video, try it on your own, and then you can come back and check your answer. We've got negative 5 divided by the binomial square root of 11 minus square root of 3. And then for your answer, you should have negative 5 square root of 11 minus 5 square root of 3, all divided by 8. So that is the lesson. But before you can start your homework, you have to say, rationalize binomial denominators by multiplying by its conjugates 10 times as fast as you can. Go!